and that it is constantly changing. Most of the changes occur so slowly that they cannot be seen in a man's lifetime. Yet we can read the story of these changes in the rocks that form the Earth's crust. We can learn how land masses are pushed up from the floor of the sea, how a plain becomes a mountain range, and how the Earth is worn away. This is a story of our changing Earth. The surface of the Earth is billions of years old. It was not always solid as we think of it today. It is believed that the Earth was hot molten rock when it was first formed. Gradually, over a long period of time, the surface of the Earth began to cool and harden. If we could cut the Earth in half, we could see how, in time, the crust formed a very thin layer around the Earth, like a coat of paint over a ball. With the passing of many thousands of years, the cooling crust began to shrink. Wrinkles were formed on its surface, wrinkles that became mountains, hills, and valleys. As the crust continued to cool, steam and other gases escaped through cracks and formed the atmosphere. Gradually, the steam cooled and condensed into tiny drops of water, which became heavier and heavier until they fell as rain. It rained for years and years. Low places on the crust were filled in with water, forming the oceans, lakes, and seas. Today, nearly 3/4 of the Earth's crust is covered by water. The core, or center of the Earth, is believed to be metallic. Surrounding this is a layer called the mantle. Above the mantle is the crust, a thin, hard shell covering the entire Earth. The crust of the Earth is in constant change. Everywhere it is being worn away by the forces of nature. This process is called erosion. One of the forces wearing down the crust is the action of the sea. The waves strike rocks, wearing away particles that are carried into the sea. Rainwater also contains chemicals which help to dissolve and break down rocks. Water also gets into tiny crevices of rocks, freezes and expands, cracking the rocks. Small plants can now find a foothold in rock crumbled by the work of ice, frost, and rain. Larger plants change the Earth's crust by spreading their roots through the cracks. The roots expand and widen the openings until the rocks crack apart. Rocks loosened by the action of rain, ice, and plants are further broken down by gravity. It takes a long, long time. Every rock, every mountain is slowly being worn away. In some regions, moving rivers of ice called glaciers grind and crush solid rock into loose particles and carry them to other areas. In the wearing down process, rocks are gradually broken apart, ground down into smaller and smaller pieces. Wind changes the Earth's crust by picking up tiny bits of sand and gravel, using them as grinding tools to cut away rocks. Softer parts of the rock are worn away first, leaving strange shapes like these. Of all the forces that are wearing away the Earth's crust, the most powerful and destructive is running water. As it moves, it picks up particles of rocks and other material from the Earth's surface. Millions of tons of topsoil are carried to the sea every day by the rivers of the world. How does a mountain wear away? Let's find out. The shape of a mountain often reveals its age. The jagged and irregular peaks here indicate a young mountain. Over a long period of time, air, wind, rain, and ice wear down the peaks and smooth off the surface. This is the shape of a mature mountain. In old age, the mountain is reduced to nearly the level of the surrounding flat land. Worn down to the level of the plain, the mountain has been carried to the sea. All exposed land is constantly being broken down and carried to the sea. If there were no way for the land to rise up, the ocean would today cover the entire surface of the Earth. Without dry land, there would be no people on Earth. How do mountains stay above the sea? This diagram represents a large mountain range. Mountains have roots sinking deep into the Earth. Scientists believe that mountains are floating on a layer of rock. Two great forces act upon the crust: the force from the weight of mountains pressing down, and the force from the rock layer beneath pushing up. Between these two forces, the rocks adjust their positions until a state of balance is reached. What happens when the top of a mountain is worn away? The mountain becomes lighter. The balance is upset, and the force pushing up becomes stronger. The entire mountain rises until the forces become equal again. As the top of the mountain continues to wear away, eventually the entire mountain range is removed. Entire mountain ranges have been pushed up, but often only a small section of land is raised. Since forces within the Earth are constantly acting on the crust, it gives way at its weakest points by developing cracks. Along the lines of these cracks, sections of rock slip and move to relieve stresses. Any place where two sections of the land move in relation to each other along the line of a crack is called a fault. It may be only a fraction of an inch. It may be many thousands of feet. Sometimes rocks will move without faulting. Under tremendous stress, a rock layer will bend. These rock strata are being bent upwards due to forces exerted beneath their center. This bending of the Earth's crust is called folding. Like most rock changes, this is a slow process taking many, many years. The curved lines of the rock layers here tell us that this rock mass has been folded. Rocks may be folded upwards or downwards. Folding and faulting are found in every mountainside. They furnish important evidence about the origin of mountains. Folding and faulting are often responsible for sudden movements of the Earth's crust called earthquakes. Watch closely as we reconstruct with drawings the events leading to and causing an earthquake. Here, forces pushing up in the center and from the sides have caused the rock layers to fault. Normally, the rocks under stress would slip upward. Compression from adjoining rocks prevents slipping. Under tremendous stress, huge areas of rock actually bend until their limit is reached. Then the rocks snap into their new positions. A sudden movement or slipping of part of the Earth's crust is the cause of an earthquake. In this way, more land is pushed up, exposing fresh rock. But eventually it is worn away again and carried to the sea. The fast-moving waters of the river enable it to carry along the particles of rock and soil. The river's current slows as it empties into the sea. This slowing of the river's current causes the particles to fall. Owing to their size and density, the largest particles fall first, nearest the shore. Smaller pebbles and lighter sands are carried out farther. The finest sand and tiny clay particles travel out much farther. When these fragments of mud, sand, and clay fall to the bottom of the sea, they are called sediments. As the river continues to drop its load, layer upon layer is built up. A trough develops as the sediments sink deeper and deeper into the denser layers below. This is a slow process, taking many millions of years. When the sediments reach a thickness of 40 to 50,000 feet, certain forces, not yet completely understood by scientists, have begun to press against them from the sides. Under intense compression and heat, the lower layers of sedimentary rock lose their strength, soften, and begin to flow. The upper layers, remaining hard, fold and fault. As the entire area is uplifted over a long period of time, a mountain range is developed. A mountain range and a broad plateau now stand where there was once a shallow sea. Within the mountain range, changes are still taking place. Pockets in the Earth's crust are now formed by hot molten rock called magma. Slowly, the magma works its way up to the surface. The magma usually cools as it nears the top of the crust. Sometimes the magma forces its way up and through the top of the crust. Hot magma, gases, and shattered rocks are forced out. Magma flowing out upon the Earth's surface is called lava. The lava, rock, and ashes shot out of the opening soon cool. A layer of rock is formed, then a layer of ash. As the eruptions continue, layer after layer pile up until a mound is formed. Such a mound or mountain is called a volcano. The volcano grows higher and higher. Some volcanoes have reached a height of more than 5 miles. In many instances, the lava does not flow out of the top of the crater, but through cracks in the sides. In time, the volcano dies down. The lava in the center hardens, and sooner or later, like all mountains, it will be worn away by the air, wind, and water. We are sure of 2 things about our Earth: that it is very old and that it is constantly changing. Most of the changes occur so slowly that they cannot be seen in a man's lifetime. Yet we can read the story of these changes in the rocks that form the Earth's crust. We can learn how land masses are pushed up from the floor of the sea, how a plain becomes a mountain range, and how the earth is worn away. This is a story of our changing earth.